2a. Didn't have to do it. 1b. Sure can. Make sure I'm in radians. I think I am. Clear whatever I have here. Left side, x minus 2 sine x. Right side, 0, which is going to be the x-axis. I probably could have just skipped graphing it and said, look at, well, no, I want to find where they cross. So I guess I do need to graph it. View window. Did they give me a domain? No. You know, I'm not sure what this looks like. I'm going to go from negative 3 pi to 3 pi. And I don't know, negative, oh, scale. My fallback is pi by 6. Let's try this for now. Is that okay? Hit graph. Oh, that's what that looks like. That's a little strange. First of all, how many answers are there? 1, 2, 3. I can probably zoom in a bit more. How about from negative pi to pi to pi? There we go. Let's try that. And I can be fairly sure. I think, Dominique, the graph continues that way in this, but it's not suddenly going to turn back out at 1,000,000 and suddenly I have another intersection point. Is that good so far? Okay. Second function, trace, intersection. First curve, second curve. Guess. Click. There's the first one. And can you take it from there? I'm pretty sure 0. How'd you do on number 5? What's the answer to number 5? Why is it B? So here's what happened. I graphed this and I went, okay, I don't know what this looks like. Cos 3x plus a half x and 0. I said view window, I don't know, negative 3 pi to 3 pi. And I went, said, okay. Let's zoom in a little bit. So I went window, negative pi to pi. I said, oh, 1, 2, 3, 4. That double root right there. 2, 3, 4. And then I went and looked in the back, and the back said 3. I said, what? I don't know if you ever tried this button on your calculator. I'll show you a neat new one. On the zoom button, option 1 is zoom box. And what that lets you do is, using your arrow keys, you can move a little cursor around. See the little plus sign moving around there? And I'm kind of wondering, maybe this one here, this root, maybe it doesn't quite touch. It looks like it does. And zoom box, if you hit enter, once you're in zoom box, it lets you literally draw a little box. That will be my new screen. That's also another way you can zoom in on an area that you're really interested in. And as it turns out, when I zoomed in, I went, ah, does it actually touch the x-axis? Does it actually touch the x? Not quite. Sly dogs, them. Limitations of the screen resolution. If you haven't clued in, your graphing calculators do not have a retinal display or anything close to that. They're pretty old technology. That's why the answer is 3 and not 4. Am I going to give you one like that on your test? Yeah, probably not, but whatever. Any others? Then, let's turn to lesson 4. Says this, solving equations involving multiple angles. What we're really going to ask ourselves today is a very simple question. Trevor, we're going to say, what if they give us a trig equation, but there's a coefficient inside in front of the x, like a 2? or a 1/2 or a 3 or something. There's a couple of ways to do these. I can teach you a method to solve these. What I'm going to do instead is I'm going to say, you know what? I'm going to teach you how to solve it as though it wasn't there, and then just tweak our answer like we did with the domain change. We said, you know, we can ignore it temporarily and just tweak our answer. Because that way I don't have to teach you a whole new skill. I can tie it into something you already know. Okay? And blah, 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 blah. Actually, what I want you to do is turn to page 331. Example 2. It says, consider this equation. Find the exact values using an algebraic approach. Now, Ryan, you have to catch that there is a coefficient. Every year, I'm going to give you one of these on your test on the written section. I guarantee it. And every year, I have kids, for some reason, and they don't even see that 2 there. They just solve it as though there's an x, and I can't give them anything because that's a completely different equation. So you have to notice that there is a 2 there. Sorry, it just jumped all of a sudden. And that 2 bugs us. So temporarily, we're going to get rid of it. Emily, here's what I'm going to say. I'm going to temporarily let a equal 2x. Write that down. Yeah, get your pencil out. And that's going to give me a new equation of cosine of a equals negative 1/2. By the way, the reason I use a, I used to use x, but then I had an x there and an x there, and it was confusing. And I've noticed they almost never use the letter a in the original equations. I'll use that. If they put an a there, I'd call it b, whatever. That's the first thing I'm going to do. Because doesn't this equation look much nicer now? In fact, I would argue I know how to solve this. Cast rule, cosine, negative or positive, Mitsu. Do I have a triangle with a 1 and a 2 in it? Okay, so we're going to come to that in just a second. I'm also going to make a note of one more important thing. This 2 changes the period. The period of this graph is going to be 2 pi over b, which in this case is a 2. In lowest terms, that's going to come in handy later too. That's going to come in handy later. So, Ryan, my approach when they give me a yucky coefficient inside... Oh, by the way, what I can't do is just pull a 2 out somehow. Every year I see some kid, oh, just do that. No, you can't factor. It's locked inside the trig function. You can't do that. I'm going to solve this. C-A-S-T. Cosine is negative here and here. Do I have a triangle with a 1 and a 2 in it? Yeah, this is the 1, 2, root 3 triangle. Which angle has a cosine of 1 over 2, the bottom one or the top one? Top one, which is how big, Ellen? You're telling me that this is pi by 3 and this is pi by 3. Right? You did say pi by 3, didn't you? Nod, nod. Oh, you had it. I gave you a chance, Ellen. She said, yeah, yes, absolutely, sir, Mr. Dueck, sir. Yes, because I never make mistakes. Ellen, redeem yourself. How big is the first a value? How big is the second a value? 4 pi by 3. Of course, that's not what we were asked to find. That's not what we were asked to find. Okay. Don't write this next line down for 1 second. I'm going to move this up here. Don't write this down for 1 second. Don't write that down yet. Asar, can you read this statement, this substitution to me, please? Louder again, you're right. Wouldn't it be fair for me to then say, you know what? 2x1, because a is the same as 2x, a1 would be the same as 2x1. 2x1, which is what I want to find, is equal to 2 pi over 3. Write that down. Now we unsubstitute. We temporarily get rid of the yucky thing by replacing it with something nicer, like the letter A. Solve. And then re-replace the original back. Except, Carly, how would I get the x by itself? Even easier, how would I get the x by itself? Divide by 2. Dividing by 2 means I'm going to end up with an extra 2 down here. So instead of a 3 down here, what will I have? Or in lowest terms, pi by 3. There's my first answer. Oh, not only is A1 the same as 2x1, I think A2 is the same as 2x2. I think I can also say over here, twice the second x value comes from my second A value. Again, Kara, how would I get the x2 by itself? Which is the same as putting an extra 2 in the bottom. So instead of a 3 down there, what will I have? I'll have 4 pi over... Oh, let's try and go in lowest terms right away. 4 pi over 6 is what? I think 2 pi over 3. Those are my roots. Let's graph this and see what this looks like. Let's all get our graphing calculators out. Clear any equations you have there. Cos 2x negative 1/2 window. Did they give me a domain in part A? Oh yeah, what? Oh, 0 to 2 pi. What's my scale? Well, you know what? I'm not going to go pi by 6 this time because, Sandali, what's my denominator here? What's my denominator here? You know what a clever scale would be? I think pi by 3, because then each hash mark should be hopefully where it crosses. Why not? Be clever. Y min. What's the amplitude right here? 1. I'll go from, how about negative 3 to 3. That's usually my fallback if I'm not quite sure what the graph looks like. And hit graph. Get this? Uh-oh. How many answers are there? Too slow. How many answers are there? 4. How many do I have? 2. How can I find the next 2? Wait a minute. What? Add. Ah, I got to cut Dominique off. Dominique said add 2 pi. I said, no, that would be if the period was 2 pi. I do agree that this one and this one go together, and they are separated by the period, which was, in this case, since there's a period change, what? We can find, take the first primary answer, add the period, that'll give us the next one. Take the second primary answer, add the period, that'll give us the next one. Except we're going to get even more clever than that. So, x3 is the first answer plus pi. Except, Dominique, what's my denominator here? Instead of writing pi, what should I write? Which is still pi, but looks much nicer. Let's go 3 pi over 3, because then I can go in my head 1 pi over 3 plus 3 pi over 3. You know what my third answer is? 4 pi by 3. That came from adding the period to the first answer. We should also be able to find a fourth x value by adding the period to the second answer. Well, let's see if we can do this in our heads. 2 pi by 3 and 3 pi by 3, the period. Emily is what? That's all of them. That's all of them. So that's going to be our method, Brianna. If they give us a period change, we kind of ignore it. Temporarily, sort of. We will write down the period because I don't want to make the sloppy mistake that Dominique did accidentally and start adding 2 pi out of habit, or if it's ugly cousin pi out of habit. I want to make sure I add the correct period. But then solve it and then unsubstitute. And it's usually going to be a pretty unsubstitution. Hey, what if there had been a 3 there? I'd have a 3 there. To get the x by itself, I would have ended up dividing my primary answers by 3. It'd be a 9 down there. Ah, B. B says state the general solution. Now, the general solution, Ryan, that was our mathematical list of all the infinite number of solutions in every direction. It's going to be almost the same as we did a few days ago. We're going to take our first 2 primary ones. X1 was pi by 3. X2 was 2 pi by 3. And we're going to add multiples of the period, but we can't be sloppy this time because last time it was we were either adding 2 pi, if it was sine or cosine or secant or cosecant, or pi. Now we'll have to just make sure we get the correct period. Justin, what's the period of this particular graph? What did we say it was? So I'm going to go plus multiples of pi. So pi n, where n is an integer. That's how I'll deal with period changes. Oh, it says complete the following statement. The general solution consists of answers which differ by blank radians because the graph has a period of blank radians. Oh. I think they differ by pi radians because there's a period of pi radians. In fact, I could rattle them off really easy. 4 pi by 3. You know what the next one is? 7 pi by 3. 10 pi by 3 plus 3 pi by 13 pi by 3 plus 3. 16 pi by 3, 19 pi by 3, 22 pi by 3, 25 pi by 3, 28 pi by 3, 31 pi. I can keep going. Just keep adding 3 pi by 3, rattling them off. Those are the ones that are generated by my first x value. What about the second x value? Oh, 5 pi by 3, 8 pi by 3, 11 pi by 3, 14 pi by 3, 17 pi by 3, and keep going. They all come from there. That's it. Oh, let's practice a couple more. Let's go back to example 1. Now it wants us to use a graphical approach. I'm going to just cross out using a graphical approach, and we're going to do this algebraically. Unfortunately, they haven't given us enough room. We're going to kind of end up writing sort of all over the place here, but that's okay. What don't I like about this? There's a 2x. Fine. Replace it with another nice letter. My default letter, Maria, A. Ooh, careful. Ugly cousin. Alex, what's the period? Yeah, pi over, so for cosine and secant and cosecant and whichever one I miss, it's 2 pi over b. For cotangent and tangent, it's pi over b, which in this case is pi over 2, because b is the number in front of the x. Okay. Let's solve this equation then. Tan A equals root 3. C-A-S-T. Eric, which trig function? Negative or positive? Where? I guess here and here. By the way, Eric, this is actually a fraction. What's on the bottom of this fraction? It's invisible. So do I have a triangle with a root 3 and a 1 in it? Oh, which one? I usually call it the 1, 2, root 3. What's my reference angle? Which angle has a tangent of root 3 over 1? The bottom one or the top one? Ellen. You're telling me that when I go opposite over adjacent, I'll ignore you. You're having an off day. Okay, how big is the top one? Ellen. I agree. That's pi by 3, and that's pi by 3. So I think My first a value is pi by 3. My second a value is, am I right, 4 pi by 3? Except they didn't want me to find a. What's the variable in my original equation, Justin? Well, the variable, x. See this statement? If I know a, how would I get the x by itself? If I know a, how would I get the x by itself? Oh, I think x1 is pi by 6, isn't it? Pi by 3 with another 2 on the bottom. Normally I'd show that step, but we're not going to have enough room, trust me. So I'm having to do a little bit more in my head. That's good too. And I think x2 would be 4 pi by 6, which I know reduces. I'm going to leave everything with a common denominator for now. Now, if I gave this to you as a multiple choice, I would have reduced the answer, but can I assume, Jimmy, that you'll be okay in spotting 2 pi by 3 as your answer from this? And I don't, okay. Are there more? Could be. There could be an x3. What would it be? Oh, Alex, what did you tell me the period was? Except if I was really clever, how would I write the period instead? Yeah. Because I think the next answer is going to be 1 pi by 6 plus 3 pi by 6. What's the next answer, Alex? 1 pi by 6 plus 3 pi by 6. 4 pi. Oh! Wait a minute. I already have 4 pi by 6. It turned out if I add the period to this first one, it gave me the second one. Asar, do I need to write it twice? Nah. So now let's add the period to the second one. Now, Alex, 4 pi by 6 and 3 pi by 6. Oh, wait a minute. Let's write it down. Now, you'll notice this time I didn't graph it ahead of time. I don't know how many answers there are. When will I stop? When I get to 2 pi. When I get bigger than 2 pi. Except, what's my denominator here, Alex? What's my denominator here? 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 When I get to 12 pi by 6. Brianna, that's 2 pi, yes? So, Brianna, add the period to my third answer. What do we get? 7 and 3. Come on, help me out here, folks. Is that bigger than the period? Are we out of the domain yet? No. Oh, add the period to this one. What are we at, Brianna? 13. Is that out of the domain of... Okay, there's 4. And I didn't need to graph to find out. There's 4. So that's what you can do if you're not quite sure how many answers there are and you're too lazy to graph or whatever. Because you're going to have to find them anyways. Often I won't even bother graphing first. I'll see if I can find them all, stop when I get to the domain, and then I'll use the graph to see that I did it right. Instead of cheating ahead of time, counting, and then stopping. Oh, B says state the general solution. Okay. Don't write this down. Don't write this down. Normally I would go like this. X1 pi by 6. X2, don't write this down. 4 pi by 6 plus multiples of the period, which is pi by 2, by the way. And I would not take marks off if you did that. I would give you full marks. But can you see this one here is redundant? Because when I added the pi by 2 to the first root, it gave me the second one anyways. So this one, strangely enough, because tangent is the ugly cousin, write this down. I think we can say x1 is just the first answer plus multiples of the period, and that will generate all of them, including the second one that we normally couldn't get right away. Again, if you missed that, would I take marks off if you listed both and added the period? No. But am I going to write extra stuff that I don't need to? Oh. Complete the following statement. The general solution consists of answers which differ by blank radians because tangent 2x has a period of blank radians. I think they differ by pi by 2 radians because the period is pi by 2 radians. One more. Example, warm-up 3. What's in front of the x this time? A 3. Wonder how many answers there will be this time. There is a pattern, by the way, but let's pretend we don't know, or maybe you haven't spotted it yet anyway. I don't like that 3, Vlad. A equals 3x temporarily. Oh, and the period is going to be 2 pi over 3. 2 pi over b. So I'm going to solve... Oh, use a different color than red, Mr. Dueck. Sine A equals... Oh, by the way, root 2 over 2, that's really the same as 1 over root 2. How many root 2's in the bottom? 2, because it's a 2 there. There's a root 2 squared. How many root 2's on the top? 1. How many left to where? 1 on the bottom. So I'm going to solve this. Joel, which trig function? Positive or negative? Do I have a triangle with a 1 and a root 2 in it? Yeah, I do. Eric, which one? The root 2, 1, the 1, root 2, 1, the 1. Okay, well, I usually call it the 1, 1, root 2 myself, but I haven't tried to figure you out for a while. Yoink. Wow, that's terrible. Where this is the reference angle. Eric, how big is that reference angle right there? Oh, we can write that down. Reference angle, it says pi by 4. Oh, and quadrants 1 and 2. So this is pi by 4, this is pi by 4. Which means, how big is A1? Pi by 3? I don't know why I wrote the reference angles. I even said pi by 4, didn't I? We'll just call that lning. Now you won't ever get that wrong. Good. Mission accomplished. How big is A1? I think pi by 4, yes? How big is A2? I think 3 pi by 4. Except I don't want to find A. I want to find X. From this line right here. Tyler, if I know A, how could I get the X by itself? Dividing by 3 puts an extra 3 in the bottom there. So you ready? The first X value, pi over 12. What's the second X value? Take my second one and stick an extra 3 in the bottom there. 3 pi over 12, which I know is pi over 4, but let's keep a common denominator to keep our life easier. What's the next one? Add the period. Except, Trevor, what's my denominator here? Here. What should it be here? Times by 4 times by 4. Right? Okay. Add 8 pi by 12 to 1 pi by 12. What's the next one, Eric? Yep. Oh, by the way, when will we stop when we get to 2 pi, which is how many 12ths? 24. We'll stop when we get to 24. Add the period to this one, Justin. What do I get? Yep. Still in the domain. Spencer, add the period to this one. What do I get? 9 and 8. This and this, right? Sure, you with me now? 17 pi by 12. Still within the domain, yes? Okay, Kara, add the period to this one. 11 pi by 12 and 8 pi by 12 is what? 19 pi by 12, still good. Okay, Caitlin, add the period to this one. 17 pi by 12 and 8 pi by 12. 17 plus 8, Caitlin. Did you say 25? We just got past our domain, didn't we? There's 6. Now, I kind of knew that because they had 6 blanks, but no, there's 6. I don't quite like the way they listed them with ORs. I usually like going x1, x2, x3, x4, x5, x6, but whatever. There's all 6 answers. Oh, what about the general solution? The general solution is going to be the first 2. The first 2 plus multiples of the period. 2 pi n over 3. 2 pi by 3 n, where n is an integer. Or you could have written, instead of 2 pi by 3, you could have gone with the common denominator, 8 pi by 12. I'm fine with that. Oh, and Trevor, I would probably, if this was multiple choice, not write that as 3 over 12. It would be written as pi over 4. I'd reduce it. But in my written work, cut myself some slack. Why not? Hey, when this number got bigger, when it became a 3 instead of a 2, how many answers did you get? 6. What do you think if there's a 4 there? How many answers are you looking for? 8. What if there's a 5 there? How many answers are you looking for? Now, the odds are if there's a 5 there, I'll just ask you for the general solution flat out. I won't ask you to list all 10. That's a lot of work. Okay, if putting a bigger number there gives you more answers, what if there's a fraction there, do you think? What would that do? Sometimes gives you fewer. That's for you to find out in the homework. That's it, period change. Going to be one of those on your test. In fact, I think it's the first written question. What's your homework? Number 1, accept cross out using a graphical approach. Number 2, accept cross out using a graphical approach. You can check your answer. Number 3, you know what I want you to cross out in number 3 though, Brianna? Apparently not. Okay. Number 4 is great, except instead of root 2 over 2, I'm pretty sure that's 1 over root 2. 5's good. 6 is good, except instead of 2 root 3 over 3, I'm pretty sure this is just 2 over root 3. Do I have a triangle with a 2 and a root 3 in it? Eric thinks we do. Skip 7. Skip 8. 9 is good. 11 is good. Mr. Dueck? Yeah, Tyler. Look at number 11, and it says equals 0.48. We don't have a triangle with a 0.48 in it. Oh, here you'll find the reference angle by going second function sign. And you'll get decimal answers, and you'll have to do the whole thing on your calculator decimally. Oh, pi minus, or 2 pi minus, or 2, whatever. And instead of adding multiples of whatever the period is, you'll actually change the period to a decimal and add multiples therein. Is that all right? That's it.